take notes on the meeting notes, but I'll narrate what you're saying, but I want to talk about your results, some successes, and then dive into the bulk of the meeting being practicing the reteach little portion that you're going to do. So you had 51% as proficient, and then an average of 64% on the test.
Okay.
So looking at the data in Illuminate, what are some bright spots?
In Illuminate?
Mm-hmm. That you summarized on your DDI worksheet.
Under the DDI worksheet, or am I looking
It's the
at
same data.
So, okay. I guess the bright spots are that the goals for the unit, or like the things that were taught through this unit, were very proficient. If we look at,
So like, what is one specific learning goal or standard that scholars did really well on?
they did really well with states of matter, phase changes, energy types and transformations, energy sources.
Right, so let's dive into energy types and transformations.
But I think that was more remembered from, that was more Unit 2 than Unit 3,
Okay.
right? And it was like the stuff that was actually like it was kind of unit specific, because it actually like transformed from renewable and non-renewable, right? Because it's like, it kind of spiraled.
So let's dive into, states of matter and phase changes, that was like Unit 1. And energy types and transformation energy sources, that was Unit 2. So that's telling me that, like, you're doing a great job of spiraling old information back in.
Yeah.
So what actions or what did you do in your planning to lead to states of matter being super high and energy types and transformations being super high?
What I did was I kept adding Unit 1 and Unit 2 questions into Do Now, so that it still stayed fresh in their mind and they still remembered previous learning goals. Because when we don't use certain learning goals, or we don't ask those questions, what happens is that 9 times out of 10 we tend to forget.
Anything you did beyond particular states of matter, energy types, anything you did beyond just putting them in the Do Nows?
I would sometimes add them into elicits, like especially if I wanted them to describe how they knew the different steps, or what it was, how it changes state from one state to the next, going from a liquid to a solid.
Can you give me an example?
Pretty much using the question of what two types of phase changes can occur in water.
And that would tie into the lesson for that
And that
day.
would tie into the lesson for the day, especially if we were talking about hydroelectric energy being something that was either renewable or non-renewable.
Great, because science does have lots of connections. So some of the things I wrote down was you added Unit 1 and Unit 2 questions into Do Nows, and you tied previous content into your elicit sections to build into the content for that day. Those are things that I'm typing down here, because those successes we want to continue into this unit, and I did notice, and that's one of the things that I wrote down, is that some of your highest areas were from last unit. So let's look at, find a standard from this unit, new material, that scholars did well on, a success.
For this unit would be, I guess it would be rocks and small scale changes, where it was.
And what do you think led to the success?
I think for a fact is that they were able to see the different types of rocks. They were able to.
Because you did a lab.
I did different types of labs, so they were able to tell the different types of tests that were performed on rocks. So that's one of the things that they did remember. So they were able to answer those questions. When it came to minerals, they didn't do as well. It's like they remembered rocks, but minerals they fell short when it came to, they kept thinking, like, it's like when I was looking, it was just like some of their questions were asked on which one was not organic matter, and they kept thinking of it as something that had to be organic, as something that was sedimentary.
So I'm going to put into your other action items, make notes in your rock, minerals, labs for next year, since you're good at making notes for next year, to address minerals, to target minerals. Alright, one of the things, so whenever you do labs with your kids, they do well.
Mm-hmm.
And you have such strong classroom management that I think we can build upon that strength, especially in this upcoming unit. Food chain is tough to do labs with, but you experienced success in Unit 1 when you did that activity where they were acting the scenario out, doing the kinesthetic learning activities. So I think we can push kind of in that direction.
Okay.
You know, so-and-so is a cheetah, so-and-so is a lion, or so-and-so is the sun, and so-and-so is a molecule, those kinds of things. Alright, so I want to dive into the reteach. So if you pull up your DDI,
Okay.
this is on the bottom. So I'm on page, what page is this? 4.
4.
Item level analysis.
Okay.
So it looks like you chose to, in multiple choice, to zoom into Earth's surface materials, thermal energy, Earth's energy and water, and rocks, because those are the priority standards. All of the explanations you gave here for these multiple choice made sense, and the quick way to address these in the do now. And I want to go into the reteach. So go to page 11. So you wrote down for the reteach objective energy in Earth's water. What about energy in Earth's water?
What I needed to do, or what I need to do, especially for this Unit 4, it comes back to energy in Earth's water, because they're talking about the food web, and they're actually talking about how it's a cycle. Well, through the whole unit, it's describing how the ecosystem is interconnected. So there's other factors that actually like overlay what's happening around. So it's like goes back towards keystone species, and if certain factors weren't available, what would happen?
I'm hearing cycle.
So yeah, so it's like, because I keep hearing the cycle portion of it, I wanted to spiral the water cycle into there so that they would realize that, okay, even though it's an abiotic factor, it's still a factor that's necessary, right? Because that goes right into my lesson of keystone species and different factors on the food web. Well, it's also going to help interconnect my future lessons on abiotic and biotic factors.
So let's be more specific then, because with this objective, it's not just in general energy in Earth's water. What specifically is going to happen in this lesson?
Specifically, what's going to happen is that I needed this picture in order to show the different transitions that happen within the water cycle. So just like that's a cycle, the food cycle is a cycle as well.
So what do you want scholars to be able to know by the end of this lesson? Because this isn't an objective, this is a topic. That's okay, let's make it.
Oops. Alright, so the objective for that day, the reason I'm spiraling this in, so the objective for that day is to have scholars understand and describe understand and describe well, they have 3 objectives actually. So they're going to understand and describe the keystone species. They're going to understand and describe how different cycles are interconnected. And they're going to understand how the water cycle helps out with the ecosystem.
So the last 2 are what's aligned to this, because the purpose of the reteach is to address the misconception that they missed on the IA. So the second thing I heard you say is they're going something to the effect of understand that it's a cycle. And the third thing was to understand how the water cycle contributes to overall ecosystem health. So that's what we want to focus on for here. The keystone thing is new, so that's not our meat right here. So the students will be able to identify, what about cycle do they need to know?
That the cycles are interconnected.
Okay, students will be able to explain that cycles are interconnected. What do you mean?
that pretty much it's without one, you can't have the other, like it's needed.
And I would say furthermore, without one phase of a cycle, you can't have the other. Because, like in the water cycle, if you're missing one part, the rest can't happen. And if you don't have the water cycle, you can't have the carbon cycle and photosynthesis. So there's two pieces. It's like the micro and the macro. So does this, how does this objectively land on you? Can you read it and let me know if there's something missing, something?
No, it's good.
So students will be able to explain that cycles are interconnected. Without one, you cannot have the other. Furthermore, without one phase of a cycle, you can't have the other phases of the cycle. Great.
Okay.
So for the plan the model, it says a lesson on 111. Where is this happening in the lesson?
In the do now.
Okay.
There, one is on the do now, like on 111 it's happening within the do now. On 112 it's happening within the illicit.
Okay, so I
So
want
I
to
did
get
it
into
as
the
a-
112 one then. Because I want to see how you would model it. Because in a do now, they're trying it on their own first, and then an illicit. Pull them up. Let's take a look.
Okay. Because on 111 I'm just talking about the two ways on
I like this one on, what day is this? 112.
112.
Mm-hmm. And 111, it's in the illicit.
No, well they're both in the do now.
Hmm.
So it was just talking about the water change. So it's more the 112 than the 111.
So these two questions, so this question in your reteach, assesses more, like specifically like what phase. It's not necessarily, doesn't address that misconception they had, which is that like I heard you say and we made that objective that the students don't understand it, like you have to have all the phases for it to happen, and that all the different cycles connect.
Okay.
So why don't we
add something?
Because I like this question on 112. It's a great question. Let's dive into this one. I almost think that so the ideal answer here is runoff.
Because the ideal answer, it's like it's representing the runoff, but it's also representing how you have transpiration, you have evaporation, you have condensation and precipitation, right? And then it's like it's running off from the mountain down to the ocean.
Right. Instead of this question to reteach, I actually think you should build off of this one. This is a great question.
The second one. Okay.
Because this are just, I think, what is the ideal answer for this?
The ideal answer for this is that as the sun heats the
This
ocean.
was a cop-out exemplar, by the way.
It was.
Okay. Holding your feet to the fire, you're better than that.
Okay, it was.
So what's the ideal answer? Let me see if you have one.
Alright, so the ideal answer is as the sun heats the ocean, the water evaporates, which leads off into transpiration as the heat, as the heat reaches, or as the sun reaches the leaves,
So you're explaining the whole water cycle to
Cycle.
me. in looking at your data, the kids got the phases of the water cycle. They don't understand that you can't take out one part and still have the rest happen.
Mhm.
They don't understand how this cycle is related to another cycle.
Mhm. Okay.
So take that out. Good
Alright.
thing you didn't write. Well, no, you should always write an exemplar. And
Recopy this picture.
Mm-hmm.
And then not why.
So let's walk through the story that this is reteaching. First, they're defining runoff. And then
They described runoff, and then their
what is the answer to number 1? C or D?
C.
Okay. And then D, and then number 2, the answer is runoff. And I think that you can say, based upon the scenario, we want them to understand that it's all connected. That was their misconception. Based upon the scenario in question 2, will the insecticide end up in the precipitation? Why or why not?
Ends up in the what?
Precipitation. I would actually, instead of saying why or not, I would leave it there. What does it say on your IA? Support your answer or explain your answer?
Yep, explain your answer.
And so how does this address the misconception?
This will address the misconception because as students went and saw that so the insecticide would reach through runoff, meaning that within their cycle, it still had to circulate in order to come back down the river. Or is it the river or yeah, it's a river.
And this goes back into your reteach objective, right?
Yes.
Without one phase of a cycle, you can't have the other phases, and that, I like how you just worded it, that the cycle continues. So I want you to draft an exemplar real quick, and then I'm going to have you out loud talk to me, go through how you would review it with kiddos.
Okay.
Goodness.
Bless you.
This will help them later on understand how acid rain happens too.
I don't think I go into acid rain. I think they go in that next year, right?
They do next year, but it's good for their brain
Yeah.
to know. But
Okay.
write your exemplar, not a bad one like the last one.
Alright, missing something. The insecticide will end up in the precipitation portion of the cycle because as the water runs off into the ocean, the water will evaporate and begin the cycle again.
Say it out loud again.
The insecticide will end up in the precipitation portion of the cycle because as the water runs off into the ocean, the water will evaporate and begin the cycle again. I'm missing something.
What do you mean begin the cycle again? Go into detail. What
Yeah.
happens next? Make it like exemplar on steroids.
Yeah.
So I think the beginning is fine. Let's go from there.
Yeah,
Beginning
I'm
cycle
like the
again.
second half.
So after evaporation, then what? Because you didn't. Right now you're only
Condensation,
at
precipitation.
evaporation, right? And precipitation is what we're asking about. So you gotta close that loop. So I would say keep going. Begin the cycle again by, or not by, but however you want to keep it going. This is also a great question and tie back in human impact, which was in your last unit.
Mm-hmm.
I've seen it spelled all three ways. That's funny. I think that's funny that doesn't even know. Okay, so say it out to me again. I'm gonna listen.
Alright. The insecticide will end up in the precipitation portion of the cycle because as the water runs off into the ocean, the water cycle will begin again through evaporation, condensation, and finally precipitate into the mountains to reach the ocean.
2 additions.
Okay.
I think you should start it with yes. The insecticide will end up with the precipitation.
Okay.
Because that way we're modeling for kids. Like when it says will it, they need to say yes or no. And
Okay.
then, and finally, we didn't make the connection between the insecticide ending up in the end product, the precipitations. Because you said the insecticide will end up in the precipitation portion of the cycle because as the water runs off into the ocean, cycle will begin again through evaporation. Our condensation, evaporation, we need to say like the insecticide evaporates in the,
So it
something about like
evaporates.
the insecticide traveling with the water.
So it
You know what I mean?
evaporates into the air,
With the
towards
water.
the clouds, into condensation,
Yeah.
and finally falls back down to the earth as precipitation.
So we need to add some part in the middle where it's saying that like the insecticide is traveling with the water in the cycle. Does that make sense?
Okay. And again, as the insecticide is traveling through evaporation, through evaporation by the heated particles rising, then condensation, accumulating in the clouds, and finally precipitating through rain. Sleet and snow into the mountains to reach the ocean.
The insecticide is traveling with the water. I'd say is traveling with the water through. They need to understand like it's dissolved in the water. It's traveling. I'd say insecticide is traveling with the water through evaporation.
Okay.
With the water. I modeled this before with my old students by I had a pot of boiling water and I had red food coloring in it and I put the lid on it, you know, because of how it boils, and I put a paper towel inside the lid and I made them predict, like, do you think the paper towel is going to be just like wet from the water or do you think it's going to be red from the food coloring? And most kids said like they just let the water would evaporate, but what happened was it turned red. So. Great, so you're going to do this in the do now on the 12th. And I want to come watch. So I'm going to put it on my calendar right now.
Okay.
Right now. And let's see, you have do nows happening at 7:41, 9 o'clock. Okay. I'm thinking 9 o'clock. Does that sound good? Okay, so I'm going to put it on here. Observe, Morse, reteach. Water cycle connectedness, I'm going to call it. Sweet. Thanks, Morse, dude. You gotta go pick up your kids, don't you? Sorry! We'll edit that out.
I keep getting in trouble for my time.